Our planet is home to over 1,000 active volcanoes, but only a chosen few have unleashed staggeringly massive eruptions, earning the moniker supervolcano. Volcanic activities range from steady lava flows to colossal explosions, featuring superheated, umbrella-shaped plumes of ash, rocks, and gas, the familiar imagery associated with volcanoes. Explosive eruptions are observed in many volcanoes globally, each evaluated on the Volcanic Explosivity Index, akin to the Richter scale used for earthquake magnitude. The Volcanic Explosivity Index spans from 0 to 8, indicating the range from non-explosive to colossal explosive eruptions. A volcano's placement on this scale is linked to the volume of materials emitted during an eruption and the frequency of eruptions. At the lower end of the scale lies the relatively mild yet still lethal Hawaiian eruption, named after the typical eruption style observed in Hawaii. These eruptions often feature 1,100 degrees Celsius lava fountains that can attain speeds of 100 meters per second and soar to heights of a few hundred meters, generating intense lava flows that blanket the landscape. Despite the destruction they cause, these lava flows also contribute to the formation of new land. Next on the spectrum are strombolian eruptions, named after the stratovolcano Stromboli. These eruptions are brief, marked by explosions that create petite plumes termed fire fountains, reaching hundreds of meters in height and ejecting ash, volcanic bombs, and ballistic blocks. On the opposite end of the scale lie the formidable Plinian eruptions, renowned for their towering eruptive columns that can ascend up to 55 kilometers into the atmosphere, accompanied by high-velocity jets of magma and volcanic gases. Plinian eruptions bear the name of Pliny the Younger, who chronicled the catastrophic eruption of Mount Vesuvius in 79 AD, famously devastating Pompeii and Herculaneum. This eruption registered a magnitude of 5 on the Volcanic Explosivity Index. While the precise count remains uncertain, it's believed that approximately 20 supervolcanoes exist on Earth. However, supervolcano isn't a strictly scientific term. Coined in the 1940s, it has gained widespread usage since the 2000s and is now widely embraced by the scientific community. A volcano attains the classification of a supervolcano when it has the potential to unleash an eruption of magnitude 8 on the Volcanic Explosivity Index, expelling over 1,000 cubic kilometers of material. These eruptions are often termed super eruptions and stand as the largest and most explosive events. Preceding an eruption, magma accumulates in a subsurface chamber, and pressure steadily builds until the magma breaches the Earth's crust. The eruption results in the depletion of magma from the chamber, causing a reduction in support for the overlying rock. Insufficient support can lead to the collapse of the ground, forming a depression on the surface known as a caldera. Super eruptions create immense calderas that can exceed 50 kilometers in width. Eruptions of this scale are exceptionally rare, following the trend along the Volcanic Explosivity Index, where larger eruptions occur less frequently. However, supervolcanoes do not consistently produce colossal eruptions. At times, they generate smaller, more typical eruptions. Naples, Italy, is renowned for Mount Vesuvius, yet the region is also home to the supervolcano Campi Flegrei, one of the nearest supervolcanoes to the UK. Presently, it is known for its pungent fumaroles and emission of sulfuric acid. Within its expansive caldera lies Monte Nuovo, a cinder cone volcano formed in 1538 during an eruption that buried the medieval town of Tripergole. Volcanic activity in the region between 1982 and 1984 raised concerns about another eruption, serving as a reminder of the presence of hot and active magma beneath the surface. A magnitude 8 eruption is nearly beyond comprehension. No living individual has witnessed the eruption of a supervolcano. The most recent super eruption occurred approximately 26,500 years ago at New Zealand's Taupo volcano. The eruption of Pinatubo in the Philippines in 1991 remains vivid in living memory as one of the most sizable volcanic events. Despite ranking a 6 on the Volcanic Explosivity Index, it was about 100 times smaller than the benchmark for a supervolcano. Despite this, we can speculate on the potential magnitude of a super eruption. For instance, Yellowstone, among the world's most renowned supervolcanoes, has experienced 3 recent super eruptions in the context of our planet's history. These eruptions gave rise to the Yellowstone caldera, measuring 72 by 55 kilometers, now the location of the USA's Yellowstone National Park. The largest of these eruptions took place approximately 2.1 million years ago when the supervolcano discharged an astounding 2,450 cubic kilometers of material. Should Yellowstone experience another super eruption, the states of Wyoming, Idaho, and Montana in the vicinity would face a direct impact from colossal pyroclastic flows. These searing avalanches composed of volcanic ash, pumice, gases, and rocks can attain temperatures of 400 to 500 degrees Celsius, travel at speeds surpassing 300 km per hour, and span over 100 km. Evading a pyroclastic flow is futile. They engulf and obliterate everything in their path. The eruption of Martinique's Mount Pelée in 1902 serves as a grim reminder. A pyroclastic flow obliterated the town of Saint-Pierre, claiming all 28,000 residents during the early hours of May 8 in the wake of a smaller, magnitude 4 eruption. In the hypothetical scenario of a Yellowstone super-eruption, the impact wouldn't be limited to the immediate vicinity of the volcano. The entire continent of North America could potentially experience repercussions. An extensive area up to approximately 800 kilometers beyond the reach of pyroclastic flows might be blanketed in a dense layer of ash, with the thickness diminishing farther from the volcano. Indeed, a super-eruption would have a global impact. Volcanic eruptions possess the capacity to influence our planet's temperature. During explosive volcanic eruptions, gases, primarily water vapor, carbon dioxide, and sulfur dioxide, are propelled into Earth's stratosphere. Among these, sulfur dioxide plays a pivotal role as it reacts with water vapor, forming sulfate aerosols. These aerosols enhance the reflection of solar radiation back into space and can absorb terrestrial radiation. Consequently, this exerts a cooling effect on the lower atmosphere of the planet, potentially resulting in significant impacts on life across the globe. The colossal eruption known as the Young Toba Tuff, which occurred 74,000 years ago, was so monumental that its effects reverberated worldwide. This eruption led to the formation of a vast caldera, spanning 100 by 30 kilometers, now occupied by Indonesia's Lake Toba. The Toba catastrophe theory postulates that this immense eruption triggered a volcanic winter lasting a decade, inducing a cold and arid climate for thousands of years. The subsequent famine is believed to have drastically reduced the ancient human population to just a few thousand individuals, profoundly shaping human evolution. Nonetheless, compelling arguments contest this theory. Evidence from ice cores indicates that sulfur emissions were less significant than initially believed, implying a potentially less severe impact on the climate than previously predicted. Additionally, research reveals that no species, besides humans, experienced a population decline, and the fossil record of Asian mammals doesn't support the idea of a mass extinction. Collectively, these findings cast doubt on the likelihood of the theory that posits our ancestry from a small group of survivors following this event. However, it is well established that volcanic eruptions, even those falling short of being categorized as super-eruptions, have influenced the Earth's climate and affected global populations. Approximately 3 megatons of sulfur were released into the atmosphere during the 1991 eruption of Mount Pinatubo, causing a global drop in air temperature of 0.5 degrees Celsius during the period of 1991 to 1993. Looking further back, the eruption of Krakatau in August 1883 led to a 0.6 degrees Celsius cooling of the Earth for several months, and the minute particles it emitted caused the Moon to appear blue for a year. Prior to this, the colossal magnitude 7 eruption of Tambora in Indonesia in 1815 had an even more pronounced impact on the planet. The subsequent year, 1816, earned the moniker, Year Without Summer. This massive eruption claimed an estimated 60,000 lives and triggered crop failure, famine, and anomalous weather. Predicting when a supervolcano will erupt is challenging as volcanoes don't adhere to a precise schedule. Nevertheless, we understand that the likelihood of a supervolcanic eruption transpiring within our lifetimes is exceedingly low. While pinpointing the exact timing of volcanic eruptions remains a challenging endeavor, advancements in short-term eruption predictions are continuously improving. Volcanoes exhibit early signs of potential eruptions in the hours or even years leading up to the event. These signs encompass anomalies in heat, variations in fumarolic gas levels, detectable seismic activity through seismographs, and alterations in the Earth's surface, observable through satellites and surveying equipment. The identification of these warning signals has been instrumental in saving numerous lives. Predicting a volcanic eruption in the distant future is a much more challenging task, but studying past eruption patterns offers valuable insights to volcanologists. Plinian eruptions, of considerable magnitude, occur less frequently compared to the more constant effusive Hawaiian and Strombolian eruptions. Super eruptions, of the highest magnitude, typically take place at intervals of tens of thousands of years. The media often speculates on the possibility of another eruption from supervolcanoes like Yellowstone, discussing whether we are due for one. Yellowstone's last eruption was 630,000 years ago, and based on the average time between its eruptions, we might have another 100,000 years before the next super eruption. Moreover, there's a possibility that if Yellowstone were to erupt again, it might not manifest as a magnitude 8 caldera-forming event. It could instead be a hydrothermal explosion or a lava flow. However, when a significant eruption eventually occurs, are we adequately prepared? Some argue that we may not be as prepared as we should be, comparing our readiness for a volcanic eruption of magnitude 7 or 8 to our preparedness for an asteroid strike, which is less likely. Researchers emphasize that the 2022 eruption of Hunga Tonga Hunga Ha'apai in the South Pacific should serve as a wake-up call. Despite being a magnitude 5 eruption, it severed undersea cables, disrupting Tonga's communications for several days. The eruption also triggered tsunamis and global shockwaves, depositing ash over hundreds of kilometers, contaminating water supplies, and causing breathing difficulties. In our interconnected world, where we depend on global systems for food, energy, communications, and more, we need to ensure preparedness for any disaster, be it asteroids, pandemics, climate change, biodiversity loss, or the potential of a super eruption from an active volcano.